And final speaker of the session, Jeremy Large from the University of Oxford, who's presenting on CODiT, agent-based methods focused on vaccination B.1.617.2. So Jeremy, all floor is yours.
Thank you very much, Danny, and thanks very much to the organisers for giving me this this opportunity to present, particularly towards the end of what's been an extraordinary couple of days. And I certainly have learned a great deal about the ecosystem of population-level agent-based modelling that's been going on in the UK over the course of this pandemic. In fact, this is an activity that I have come to only, I would say, a little later than some of the other presentations that we've heard so far. In fact, it was stimulated by some conversations that I had back in September and October with another of the participants at this conference, Nicholas Beale, where he challenged me, saying at a time when there was considerable concern that the testing system that we thought the UK had in place seemed not to be mitigating the rise of a second wave as had been expected. But what is it about the test, trace, and isolate system which we could do, which we can adapt to make more effective to mitigate the rise of this second wave? Let me just share my screen at this point because this conversation gave rise to a project which we named CODiT, an open source collaboration, which I list here some my collaborators, both coders and thinkers in developing this agent-based model. We were lucky enough a couple of months later to join up with Mark Birkin, and other colleagues at the University of Leeds, as well as with Leeds City Council, who were able to give us input on this model over the course of this year. CODiT then sits alongside and perhaps slightly behind models such as June, RAMP UA, ABM Lux, and EpiSim, and InfectioNet, all of which we've heard about at this conference so far. But it interests me that the salient topics at the time when this was developed were perhaps a little different to the ones at the very outset of the CODiT epidemic and the COVID epidemic, and perhaps we have brought slightly different features to the fore in our model. We worked entirely open source, so I hope afterwards it will be possible for you to, if you wish, to go back to my slides and follow these links, such as the one I've just clicked on, which take you to more detailed information about the model that I'm presenting today. Now, I do want to try to tell a story with this model, and that will be about something of the moment, namely the question about focused vaccination, which arose only 2 or 3 weeks ago as we began to grapple with the implications of the new variant B.1.617.2. And in the spirit of being a model user, I was able to share a preliminary report with Leeds City Council about this topic 2 weeks ago. And I will illustrate these results. What's more, these results, in fact, apply a spatial aspect of CODiT. But I think it's right to say that CODiT at its inception did not put spatial structure at its core. Good. So let me just tell you a little more about the design choices then that we made in building the CODiT agent-based model. We wanted scale. We're able to simulate up to 1 million people. We want the people that we simulate to be able to make some decisions, to have quite a bit of structure to their thinking about the disease. We want them to decide whether to isolate, decide whether to go for a test, whether to divulge their contacts to a contact tracing system, and in a wide variety of ways, how exactly to comply. If we take one of those decisions, the decision about whether to get tested, we, of course, will then have to parameterize how many people it is who make that choice. And one thing we discovered in our discussions with Leeds in February was that we could not get this rate right unless we put this compliance parameter remarkably low. remarkably, that is for how we felt at the time. And I was having to drive this down well below 50%. And then, of course, news stories broke that the number stood in a survey at only 20%. Only 20% of people coming forward to get tested if they experience the symptoms of COVID-19. So this is a work in progress where we but by fitting data, we hope to be able to estimate some behavioral parameters more accurately. And of course, a behavioral parameter of the moment is vaccine hesitancy. Why have we incorporated this behavioural aspect? Well, it's so that we can compare some detailed policies. One question we asked early on was whether we should be not only asking identified contacts of an index case to isolate, but we should also be asking them to get a test and potentially propagate a virtuous circle of test and trace. So we wanted to be able to illustrate and understand the implications of these kinds of policies. Put more generally, we wanted to emphasize a focused system approach to suppressing C19. At a point in time, remember this, we're back in autumn 2020, when the system was quite fixed. In fact, we took a what the society that we were living in at the time when we did this coding was one which was going into lockdown, where our lives were somewhat curtailed, and many of us could list the individuals we regularly came into contact with, and we came into contact with those same people time after time. So this is a very different type of society to a pre-lockdown society, but led us to make an early modeling choice about using a fixed contact network, which I'll say more about in a minute. Good. Hopefully these bullets go without saying. We're in a constant dialogue with this model. So as I said, we began from a model with a fixed contact network. People with as we were all living with a narrowed life, with very little ephemeral contact in our lives. And that's a world in which people can easily indicate how many people they come into contact with a day. And of course, that was a number that varied enormously. In a family of 4, where the children were being homeschooled and the parents were able to work from home, that number may be very low indeed, 4 or perhaps 5. But for the care home worker who has shifts in 2 different care homes, that number could be very large. It could be 200. And this dispersion in a fairly constant state variable that each person carried around, namely their extent of connectivity, was really something that we wanted to focus on. Now, I think I'll rattle through some of the other elements of CODiT here, because I think we've arrived at followed the other agent-based models and implemented many similar aspects. A simulator and what we came to call a looper, meaning a way of handling that stochasticity or randomness or uncertainty, which has been raised by Martine and others over the course of this meeting as best we could. And again, I don't think there's anything too new here. I think we've seen most of these elements in other talks, but just to emphasize again the fixed nature of the contact network across which we're going to allow our disease to spread. One point worth making about that is that this network is clearly not one of perfect mixing. It incorporates a great deal of commutativity. Those people who I'm in contact with, any 2 people I'm in contact with, are relatively more likely to be in contact with each other. And cliques in the network, such as the classroom, overlap with other cliques, such as the household. And this structure is exactly where we expect, but by being explicit about this structure, this is exactly where we expected to be able to provide some incremental in intellectual insight. Good. As it happens, at the time that we created this model, there was also, as we will recall, a capacity problem with COVID testing. And so the model incorporates a backlog of tests which are at a testing center waiting to be processed. And it incorporates a group of people who are isolating while they wait for their test results to return. Now, what I wanted to do for the rest of this presentation was to just tell again that story that we, in broad strokes, the story that we have, these are discussions with Leeds recently about focused vaccination. This required us to be agile and to make adjustments quickly to our code base, because we realized we would need vaccination policies. We would also need to code variants of the disease, which was going to involve us coming back to probabilistic cross immunity and protection by vaccines. So there was some hasty coding and adaptation of our open source repository, and the state of play at the moment is, as ever, provisional, aiming towards improvements, and I've listed here some of the shortcomings that our model currently is subject to. Okay. By the way, the slides that I'm showing, they are simply rendering a Jupyter notebook. That's a way of running Python code, which any of us can reproduce afterwards. So this Jupyter notebook will be open sourced and made available to anyone to run for themselves. So to Mark's comments recently about reproducibility, even if I've done the right thing, then even this presentation will be reproducible by any one of us and by anyone else afterwards. And the slides here, they just highlight some of the significant lines of code which need to be run in order to reproduce these results. So I'll just to illustrate, I will apply this agent-based model to the region of the UK, Leeds. We'll lock down classrooms and workplaces to a certain extent to reflect the way that things were at the start of 2021. We're operating currently in a position of some uncertainty about the extent of cross-immunity from experiencing one variant from having experienced one variant to being immune to another, as well as with the efficacy of vaccine. And I have made what I think is a central parametric assumption about this cross-immunity that broadly, except when we encounter the Indian variant, we're 80% immune to acquiring this infection, having had it once before or had a vaccine. I see I'm running a little behind, so let me cross over this, but it provides a lot more information about the magnitude of various different clique structures in that we coded in our simulated digital twin of the city of Leeds. I think I mentioned earlier a crucial parameter that to set in order to be able to match observed case rate data, which is the probability of coming forward for a test if you experience symptoms of the disease. And in this simulation, I've calibrated that to 25%. That you can see that down at the bottom here if I just highlight these cells here. I'm going to create two variants of CODiT. You can think of them as two diseases which are actually circulating in the same population. They might as well be two diseases. It's just that having had one of the diseases, you become somewhat more immune to the other one. Very conscious of time. I have another 3 minutes to go, so let me just rattle through this. I'm now going to run a simulation through 2021, illustrate what CODiT can do. Here, begin January, February. in March I'll leave out, but in April we will seed, as I think happened, cases of the Indian variant into a single ward in Leeds. So, so of course I could have picked any ward. In fact, I chose a somewhat inner city ward, the ward of Chapel Allerton, because at that moment, only a couple of weeks ago, we were interested in the question of whether focused vaccination in a single locality of a city might materially mitigate the spread of this new variant. And by the end of the month, well, first of all, let me just show you where the seeded ward was. You might recognize as a map of Leeds, and in fact, we've already seen maps of this area already today. And in fact, this is a diamond shape here is the ward which I rather cruelly and quite capriciously picked on to seed the Indian variant into. But in this particular simulation, and we can discuss uncertainty more, but in this particular simulation, within only a month, so I've got here to the end of April in my simulation, we're seeing that a very significant number of infections are now arising in another ward in Leeds. And so perhaps it should come as no surprise that this targeted city ward level focused vaccination intervention has turned out not quite to be agile enough to stop the horse before the stable doors, to close the stable doors before the horse escapes and it gets out into the rest of the city. Things only get worse as we go forward through time. So by way of conclusion, we're in a fluid situation. We haven't settled this into a paper, for example. We want to do more research. Sometimes it feels that with every passing news cycle, the paper that we should write changes. And I think that illustrates the benefit of an agile code base. In this particular case, the question at hand, I think, is one that we're all quite probably unsurprised by even a couple of weeks on, which is that focused vaccination at the ward level was not sufficient in this CODiT simulation to stop the spread of B.1.617.2. Just a couple of final remarks. One I haven't written here, which is just to mention my own affiliation. Up to my right here, I mentioned that I mentioned the Oxford Business School, and I do in fact teach there quite a bit. I'm teaching there at the moment, but in fact my main affiliation is at the economics department in the University of Oxford. Having made that a clarification, our final remarks are we would very much value expert input on calibrations and parameter settings, including behavioral ones and policy parameters. We're quite willing to take this model international to the place where it will have greatest impact, quickest, and there, wherever we can find them, we're interested to work with software users who take advantage of our entirely open source data set and adapt it to their own local conditions to answer their own specific policy questions.
Okay, great. Thank you very much, Jeremy, and just in time for the end of the session. So there's a couple of questions on the chat, but I think I'm going to leave them for you to see if you can answer them either on the chat or on the Q&A. And that way we'll be able to have at least a little bit of a break in between sessions so we can take our eyes off the screen for a tiny break. But thank you very much to you, Jeremy, and indeed to all the other speakers for very accurately sticking to time. It makes the role of the chair very easy. So, Mark, should we now take a break and reconvene at 11:40?